Hello students, I am Dr. Prashanjit Mukherjee. Welcome to my channel. This video is regarding the nomenclature of complex compound. To name a complex compound, we should note that what do you mean by complex compound? Complex compound is nothing but interaction between the central metal atom and the ligands. This is a ligand and this is a central metal atom. By the means of a coordinate bond is basically called a complex compound. Okay, so if I want to name about a complex compound, we should note that the central metal atom should be there and it should be transition metal. Okay, so it should be a transition metal. So if I want to discuss about a transition metal, you know that there are metals of the origination of 3D, 4D, 5D and 6D series over here. So commonly it is being seen in our syllabus that the 3D series transition metals are being involved in the formation of complex compound. Now students, you should note one thing, that if I want to discuss about a complex compound in detail, we should note that there are some certain features of the complex compound that has to be confined for, and that features are what you see that if I take this one, this is what we have to take this as, this is what called a primary valency. If I take this one is a primary valency. This is what a secondary valency. Okay, so it is being a complex compound is always written in a square bracket with outside the periphery of the square bracket is called a primary valency and inside the periphery of the square bracket is called a secondary valency. Outside it is also known as an ionizable sphere and this is also called a non-ionizable sphere. Okay, and this is also called a non-coordinated sphere and this is also called a coordinated sphere. Okay, so irrespective of this writing out the complex compound with primary valency first and the secondary valency second, it can be in vice versa portion also. That is what secondary valency first and the primary valency second. This is also non-ionizable sphere first, ionizable sphere second, and then coordination sphere first and non-coordinated sphere second. This is what we have. We can write it out like this one. So you can involve coordination compound in this manner where you will find it out primary, secondary valency should be a main priorities over here. Okay, so how to write the rules of writing out the nomenclature of the complex compound if I want to write it out. If primary valency is written first and then the secondary valency is written, okay, the name of the metal should end up with an 8, ATE, 8. Okay, this should be valency and written first and it should be 8, ATE, 8. The suffix will be associated with 8, ATE, okay, with oxidation number in Roman under parenthesis. On the other hand, if the secondary valency is written first, okay, and then the primary valency is written, then the name of the metal will be restored as it is with specific oxidation number in Roman under parenthesis. Okay, so how will I name this one? But before that, we should note that the naming of the ligands are suffixed. There are types of ligands and one type of ligand is a negative ligand. The negative ligand ends up with a suffix O. Say chloro, Cl minus is there, chloro. Cn minus is a cyano. Okay, OH minus is a hydroxo. Like that way. Okay, positive ligands ends up with a suffix ium, I-U-M, ium. For example, NH2 NH3 plus is called a hydrazinium. H3O plus is called a hydronium. Neutral ligands, the third type of ligand is a neutral ligand. Neutral ligand has its own specific endings. Say water is there, aqua. NH3 is called amine, A-M-M-I-N-E. Okay, differences between aromatic amine and coordinated amine is what? Aromatic amines are basically NH2. This is called an amine, and coordinated amine is AMMINE, that is what? NH3. Similarly, say CO is another neutral amine, that is what basic neutral ligand, sorry, that is basically called carbonyl. Okay, now students, you have to follow some specific rules. There are tricks by which you can make the complex compound easier to name. Okay, so I'm using a trick which is called a PLMN trick. PLMN trick. Okay, this is a very super trick of it. Okay, if you can just apply this particular thing, it will be very easy for you to name the complex compound. P means positive, L means ligands, M means metal, and N means negative. Okay, so now P means positive, that means what you have, say for example, if I take it like this one, say CuNH3 whole 4 and Cl2. See, this is what a positive part. CuNH3 whole 4 is a positive part. This is very much a super trick by which you can make your complex compound easy to understand. Okay, this is a positive part. Positive. Then you name the ligand. Ligand is what? Tetraamino. Tetra, why? Because all the ligands, this is a ligand. Okay, first you see the positive part, then you see the ligand, and you write the prefixes of the ligand. This is tetraamine, tetra. Okay, tetraamine. Then you write down the oxidation state, find out the oxidation state related to it, and then write down the metal's name under parenthesis and in oxidation number on the parenthesis, and then write down the negative part. Okay, so we are following this particular rule over here. You see, first positive, then the ligands with the prefixes, then oxidation number with the metal under parenthesis, and then the negative part. Say for example, if I take it this way, this is CuNH3 whole 4 and then Cl2. So what is it? X plus 0, because neutral ligand has got 0 oxidation state. Minus 2 is equal to 0. So X becomes what? 2. Okay, so what we should name it out? You will write it out tetraamine. Tetraamine. Please be sure about this one. This is not organic nomenclatures. In organic nomenclatures, when two vowels were there, one vowel has to be dropped down. But over here, you have to restore both the vowels. Remember this. Tetraamine. This is obviously positive part we are writing. Then the ligands with the prefixes. Tetra. Why? Because 4. Tetraamine. Okay. Then metal. Metal is there. Copper. And then oxidation state in the under parenthesis 2, and chloride is there. Chloride. Okay, this is how we name the complex, but you use this particular trick, PLMN. It is quite a viable trick by which you can make your complex nomenclature very easy. Now, using the prefixes, as I have just discussed, if it's a monodentate ligands, the prefixes are used as mono, di, tri, tetra, and so on. Okay, but it's a polydentate ligand, then the prefixes are known as bis, tris, tetrakis, and so on. Tetrakis and so on. Okay, tetrakis, and so on. Okay, so if I want to write out all the nomenclatures, now we will follow all the rules whatever I have suggested to you. Say for example, this is the first nomenclature set which I am trying to write it out for you. Say AlH2O whole 6 Br3. This is obviously a positive part, that means PLMN is being used. Okay, so this is what the positive part is to be written first. Fine. Then what you should write it out, then you will write positive part you have taken, then you have got to write the ligands with the, what did I say, ligands with the prefixes. So this is what hexaaqua. Okay, aluminium, three. Okay, 3, because X plus 0 minus 3 is equal to 0, and X is coming out to be 3 over here. So this is 3, and bromide. negative part. Please be sure about this, that if it is outside the periphery of the square bracket, if it is 3, 4 times, 5 times of if it is there with the negative ligands, don't write tribromides and all. Okay, it is only written as bromide over here. Same is the case with the case of CrNH3 6Cl3. This is becoming what? Hexaamine chromium 3 chloride. Okay, then again this is what, again I have changed it. Now just see over here, you have got, this is K3, this is the positive part, hexa, this is what, the negative part over here. Now you will write positive potassium, then leave a small gap. Just see, this is a very important thing which students get to just misunderstand this one. You leave a small gap. If the primary suffix is written first, if the primary valency is written first and then the secondary valency is written, then you should name the metal with an 8 with the specific oxidation number, and you should leave a small gap. Potassium, then leave a small gap, hexafluorophorate 3. Similarly, if it's a negative ion, then you should always change into 8. Okay, so this is what, x minus 4 is equal to minus 2. So x becomes what? 2 is the oxidation state. Tetrahydroxo zincate 2 ion, zincate 2 ion. Always remember, if it is a negative, it will be, the metal will be restored with an 8 oxidation, 8 will restored with an 8. Okay, but if it is a positive, don't write, just see, don't write 8, you will write restoration of the metal itself with a specific oxidation number under parenthesis. So students, I have tried everything to write it out all the way, how to explain the nomenclature of the complex compound. Here is some task which I have trying to give it to you. You try it out, all these things. This is the writing the formulas of the compound, okay, complex compound, okay, and I have already named all the things, and try to write the formulas related to it. Okay, thank you for watching this video.